Hello, today we are going to start our work in functions, and we're going to look at some mapping diagrams that we would have touched on in junior cycle, and we're also going to look at a little bit of application type questions, more immediate type algebra type things. But before that, we have to be sure of our definitions and of the language we're going to use in functions, because it can get quite formal and we need to be very clear on it. So mapping diagrams are our ellipse shape circle type things. They look a little bit like stretched out Venn diagrams, and they say if I start out with a particular value of x, where does my function send me to? So if I start out at -3, my function changes me to having a y output of -1. And these are the three different ways of writing our function notation. Y could be equal to x plus 2, f of x could be equal to x plus 2, or f colon x sends x to x plus 2. So if we start at x is -3 and we add 2 to our x value, that gives us our y value. So this is our input, which we call the inputs we would call our domain, and the outputs of our function for a given domain is our range. Now, the type of number, there's a few different ways of defining codomain, but the type of number that you can get out of a function we call the codomain. The results that you specifically get are called the range, but the type of number you can get out of a function is called its codomain. So the domain is our x values, which is a very important word. It comes up lots of times in questions. The range is another very important word. It can come up particularly in trigonometric type questions. And codomain is less common, but still important. It can come up on the exams. It means the type of number that can come out. So are we dealing with natural numbers? For some reason, are natural numbers the only type of number that can come out of our function? Well, then our codomain would be the natural numbers. If only positive numbers, positive real numbers can come out of our function for whatever reason, that means that positive real numbers is our codomain. And positive real numbers, or will I put this in? Positive real numbers, as opposed to being called capital OR, are called OR plus for positive real numbers. And we might see that, yeah, we actually have an example of that later on. So I will remove that so it isn't a confusing little addition. But that's what our codomain is. What type of number can come out of the function, not the specific numbers. The specific numbers that can come out of the function is called the range. Now, a quick point on this. Our function is defined for real numbers going to real numbers. That means that our domain, the numbers we can put into our function, y is equal to x plus 2, we can put in any x number we like into our function x plus 2, as we'd be used to doing up until now in functions or equations or algebra. We can have any x value we like, and we can also get out any y value that we like. There's no restriction on the type of y value that we can get out of this function, because we're just adding on 2 each time. So we start with real numbers and we can get real numbers out. So our function goes from real to real. Now, if we look at our mapping diagram, something that might become apparent, though it may seem natural enough, is that for every value of x here, I have only one arrow. I have a maximum of one arrow going over to my y's. If I have x is -3 here, there's only one destination I'm going to go to. I don't have multiple y values for a single x value. And this is very important for the fundamental definition of a function. So we can have relationships between x and y, ways of describing going from x to y, where you could have a single x value creating multiple y values. We're actually going to look at an example of that, but they won't be called functions. And there are certain things about functions that we're going to go into in our work this year that make functions quite powerful, and it also restricts the types of things we would call a function. So what we would say is, in the picture format, something is a function if there's only one arrow going from anything in the domain over to our range, over to our codomain or range. If there's more than one arrow going over, that means a single x value in our relationship would give us multiple possible y values, and we would not call that a function. And that's what I've written here. A relationship between x and y is called a function if each x has only one y value, i.e. one arrow from anything in the domain. That's our definition of a function, and it's important that we know that there's a restriction on the types of relationships that we would call a function, because we're going to go into more depth on types of functions fairly soon. Now, let's get into a little bit closer to exam type questions now that we have a lot of our definitions discussed. So if I have my function here, f of x, so this is not f multiplied by x, this means a function involving x, so has x as its variable, and this is going to give me y output, so f of x is the same as y. A function involving x is equal to x squared minus 1. So the domain of this function would be any x value we like. There's no restriction there, so it's just going to be the real numbers. And what type of number could we get out? What would our codomain be? Well, we can get out any type of number we like from this function, so it would be any real number again. Now, there are real numbers we can't get out of this function, but we can't restrict it easily to saying that it's just the positive ones or just the negative ones. So we would say that if we go from real to real with this function. So this is our domain and our codomain. Now we are going to discuss, so here we have a slightly different situation than we had with our first example. This one was nice. We just had a single arrow going to a single point, single arrow going to a single point, and they were all different each time. So it looked very nice and simple. Here we have a slightly different situation. We have an x squared type function. So x is 1 would give us a y value of 0, and x is minus 1 would give us a y value of 0. So we have two different x values that go to the same y value. Now this doesn't break our rule about it being a function. There's only one arrow going from anything in the x. And just to point out to you, this is the roots of the function. This is where that is coming from. It would be 1 and minus 1 would be your roots of your function. That's what's going on here. Now, so this is a function. And one of the ways that we can test that this is a function that I meant to mention for this one as well is that we can draw a vertical line through any point in our function, and it will only cross once. So it will only cross our function line once. So I've drawn my function lines in blue. Any vertical line I want to draw at any point on my picture will only cross my function once. I can draw them anywhere I like. It will only cross my function once. So this is a test that we can use for a function, and it's a graphical way of arguing that there's only one x value for any y value. That each x value goes to one y value. So we call this the vertical line test. Vertical line test. And I will write that and come back to you. So our vertical line test, a vertical line drawn anywhere on our graph goes through f of x no more than once. It cannot go through the function more than once. Now, it can not go through the function because a function doesn't need to be defined everywhere. Like log functions, for instance, are not defined for negative values of x, but for it must go through at most once. It cannot go through multiple, they cannot cross the line, cannot cross the function multiple times, and we'll see that in just a second. Finally, the range of this function, I just want to point out the codomain is all real numbers, but what's the range of this function? The range is going to go from -1. The minimum of this function is going to be at -1, so it can go to -1, and it can go up to infinity. But we say that the function doesn't actually, we wouldn't normally say the function kind of gets to infinity. It can kind of come up to infinity, so we put a curved bracket for saying that it comes up to infinity. So if something is not included, then we would put a curved bracket. If it is included, we put a square bracket. Now, the next example is of a circle. So we've looked at circles a little bit, and this is the definition of a circle around the equation of a circle centered at the origin is exactly the same as Pythagoras' equation. So h squared is equal to x squared plus y squared. So any point on this circle has the same distance away from our center at 0, 0. So that's why this the equation of a circle looks the same as Pythagoras, because that's what it is. So this is the hypotenuse squared, or the radius squared. That means that the radius is the square root of 2. Anyway, coming back to the function point, what is going on here? If we step back from our diagram a little bit so this doesn't get too confused. What is going on here? Well, we can see that we have broken our functions rule very clearly, because if we have x is 1, so if we have x is 1, we'll say is about there. If we have x is 1, we cross the function at 2 different points. We cross the function at y is -1 and y is 1. So for one x value, we end up with 2 different y values. And I've given you another example. At x is 1 all over root 2, y is plus or minus 1 all over root 2 as well. Now, that's not to say that this happens all of the time. At x is equal to root 2, y is equal to 0, so it has just one output there. But there are lines I can draw, x values I can pick, that give me multiple y values. So this is not a function. So circles, even though we do lots of maths with them, are not functions. So we wouldn't put down, we wouldn't talk too much about their behavior, because they are not functions. They are relationships. We can describe this relationship, but they are not functions. And next video then we are going to look at some more immediate algebraic type questions.